offset window functions will return a value that is an offset from the reference point. And that reference point can be current row or edge of a frame. And based on that, we can differentiate between row offset functions and frame offset functions. I will now jump here to this web page, and here we can see how row offset functions work. So if this is current row, we will go several steps from that current row. We will go up, for example, 3 steps, or we will go down 2 steps. And to achieve this, we would use log and lead functions. So we can go up with log function, or we can go down with lead function. When we are using row offset functions, we cannot use frames. So they're used without frames. And now I will show you one example, but before that, I have to create one sample table. I will create a table with 2 columns of integer data type. First column will present months, and the other column will present a value for that month. Then I will place some data inside of that table. This is it. And then we can read from our table. Then I will execute one statement that will show us how log function works. So this is window function with log function. So we have log of the value column. We are going 2 steps up. We are using order by month. So when I run this, what will happen here? That, for example, if this is current row, we will go 2 steps above. So this is first row above, second row above. We will take this value and we will place it here. It is the same here. For 7th month, we will go to May. We will take this value and then we will place it here. So we are always reading a value from the row that is 2 rows above. I will now jump here to this web page, and here we can see how that works. So we always read the value 2 rows above. But here we can also notice that we have 3 problems. First problem is that April is missing. So we don't have 4th month. And in that case, if we go 2 rows above from the May, so May, then we have March and then February, we will take the value from February. But February is 3 months before May, not 2 months. So we should be always careful to have all of the time points when we are using log function. Next, for January and February, we have nulls. And these nulls are because we don't have previous values, so we have to return nulls. And the third thing is that here we have this null value. We'll jump here. Here is better to see. Now, from this May, if I want to go 2 steps above, I will go to first step and then to second step. But sometimes I don't want to count null as a step. I want to omit nulls. So this will be my first step and this will be second step. Now this is something that is possible to do according to SQL standard. So we have subclause ignore nulls, but this subclause will not work in Monet. It is not supported. So if we want to count this as the first step and this as a second step, so instead of having 3 steps to have 2 steps, this will not be possible in Monet because this subclause is not supported. Now log function can work with partitions, and we should always use order by for log function in order to make sense of this function. We will now talk about arguments of this log function. I will clean my screen and then I will run this statement here. And here we can see that we don't have that second argument. If the second argument is missing, so we don't know how many steps to go, in that case we would go only 1 step. We can see that this column here is offset by 1 row compared to this column here. If we have second argument, only in that case we can also provide a third argument, and that third argument is default value. Default value in this case is 77, and it will be provided when we don't have a previous value. So previously we had nulls here, but now we have 77. We should also be careful to provide the default value of data type that is compatible with the data type of a column. In this case, I have provided a default value that is of string data type, but inside the value column we have numbers. So this will not work. And if we omit this third argument, in that case, default value is null. We saw that earlier, so it will be null when we don't provide a default value. I will now clear my screen. Beside the log function, we also have lead function. Now, lead and the log functions are almost the same. They are just working in opposite directions. And I will now again give you one example of a log function. I will run this example here. We are ordering our rows by months in ascending order. So this is our order. And we are going to read the previous value, so the value from the previous row. So if this is current row, this is previous value, and we will take that value here. But we can create the same table if we use lead function. We just have to make one more correction, and that correction is that we have to change order from ascending to descending. In that case, order of this partition is from 7 to 1. So 7 is up value and 1 is down value. So if this is our current row, what is the value below it? It will be this value. So this will be up value, this will be at the top, this will be the value below it, and then we will take that value. So in this case, we would get totally same result. We are here using lead but with descending order, and here we are using lag with ascending order. We can go even further. Again, I will give you an example of log function with ascending order. So this time we are going 2 rows up. So for this row, we would get this value and we will place it here. And then I will create the same result with lead function, but I will again use ascending order. So how is that possible? Well, let's see. We got the same table. We are using lead function and we have ascending order. But look at our second argument. It is negative. We can use negative value. So lead of -2 is the same as lag of 2. So these are examples how we can create the same result by using both lag and lead functions. I will now clean my screen. Next, we will talk about frame offset functions. For frame offset functions, we are looking for an offset from the edge of a frame, so we need to have a frame. I will now go back to this web page. I will go down here, and let's assume that this is our frame. We have a function first value that will return the first value in that frame. We have a function last value that will return the last value in this frame, and we have a function end value. This function will accept an argument. In this case, that argument is 2. That means that we will take the value that is in the second row of this frame. Let's now see some examples. We will go back to terminal and I will run this example here. In this case, I have provided a frame that is range between 2 preceding and 2 following. Let's assume that this is our current row. So 2 preceding and 2 following means that 6 minus 2 and 6 plus 2. So frame is between 4 and 8. So in this case, values 5, 6, and 7 are inside of this frame for this current row. And the first value in this frame is number 5. So we will have number 5 here. And that is how first value function work. Then I will create another statement. And in this statement, we will use the last value. But this time, I will not provide a definition of a frame. We just have order by month. So what will happen now is that the default frame will be used. And that default frame is range between unbounded preceding and current row. So we are always looking for a frame that occupies a range from this first value to the current row. Let's assume that this is current row. So from this value to this current row, and so on. In this case, we are looking for the last value. So what is the last value of a frame with such definition? Well, it will always be the current row. So if we are looking for a frame between first row and the current row, the last value will be current row, so that last value will be used. I will now clean my screen, and I want to tell you that when we're using frame offset functions, we can use partitions, and we should always strive to use order by and to provide a proper definition of a frame. we have one more frame offset function, and that is end-value function. This function will accept the second argument, and that argument will tell us what row of a frame from the start we should return. Here I have one example. In this case, we are using a frame that is the same as partition, so everything will belong to this frame. Our second argument is 4. That means that we are expecting to return the fourth row in this frame that is inside of this partition, because in this case partition and frame are the same. So I will run this, and we can see that this is the first value, second, third, and this is the fourth value, and that fourth value will be returned. Now when we are using end-value function, we should always provide the second argument, so there is no default value for this second argument. If we omit that second argument, we would get an error. We should also say that with end function, we cannot provide a second argument that is negative. This is not allowed, so if we run this, we will get this message. And we can also say that end value function should be used with order by always, and we can also use partitions with end value function. I will now clear my screen. Let us now talk a little bit more about SQL standard. We'll go back to this web page, and here we can see again ignore nulls subclause. And this subclause by SQL standard can be used with frame offset functions. In this case, I'm looking for the end value in the third row. So we have first row, second row, but here is null. And because of ignore nulls, I will ignore this row, so I will take the value from the fourth row. But this is not supported in MonetDB. Beside this, there is a subclause from last. This subclause can be used only with end value function, and instead of taking, for example, second value, so value from the second row, if we use from last, we will take the second value from the end. So if this is the first row at the end, this is the second row at the end, we would get the number 6. But this is not a big problem, because we can get the same result if we change ordering to descending. So in that case, 7 will be at the top, and then below will be 6. So if we take the second value, we would actually take again number 6, so we would get the same table as this table above.